Good day, everybody. This is a slightly modified problem from David Altizio's homemade collection. Very prolific problem writer. A lot of his problems ended up in various math competitions. This particular one was an ARML math problem. Local, I don't know much about this, back in 2019. But it's a maximum value problem, y'all. And by maximum, when you say absolute maximum value, you mean for all x, a member of real numbers in this case, okay? So what we have here is a trigonometric expression, and we have something that's going to require an identity, at least the way I did it. And I've written it down for you. This is a famous trig identity that says the sine of a plus b is equal to the sine of a times cosine b plus cosine b sine a. Okay, you can prove that on the unit circle, I think. And so, y'all, by arccos, I mean the very same thing as cosine inverse. I like arccos because cosine inverse could be confused with 1 over cosine. But we mean the cosine inverse of the number 10 over 13, and that is it's an angle. The cosine inverse returns an angle just like all the other trig functions. And let's go ahead and give this a name while we're up here. Let's call this theta. So this is equal to theta. That's a common letter in trigonometry. It's often used as an unknown in trigonometry, much like x is an unknown in algebra. Okay, so since these functions are inverses, arc, cosine, and cosine, all of this just collapses into 10 over 13. Now the part that we have to actually spend some time on and figure out is the sine of arc cosine of 10 over 13. Now what I've done, folks, you may recall the definition of cosine is the adjacent side divided by the opposite side, or the hypotenuse. And so this is the adjacent side to this angle theta. And again, I'm using theta in this sense. Okay, so theta of any of cosine of theta is the adjacent side divided by the hypotenuse. Okay, but we want to know what sine of theta is. Okay, in order to see the sine, we're looking for the sine right here. The sine of theta. We're actually trying to find the sine of theta, so we need the opposite side. And just a little bit of Pythagorean's theorem here. Forces this to be the square root of 69, and that's because 10 squared plus practice competitors can just do this quickly in their head. If you've forgotten Pythagorean's theorem, this is the reason why. Squared right here, and then of course that's equal to 13 squared. And again, most of the people that or in competitions memorize all these squares. So 13 squared is 169. This is the same as 169, right? And so 10 squared is 100. The square root of 69 squared is 69. 100 plus 69 is 169, which is equal to 13 squared, all right? So we do know that the sine of theta, let me write it right over here, the sine of theta equals to the square root of 69 over 13. And that's consistent. We know all the trig functions like sine and cosine are less than 1 from the unit circle definition. And certainly this number is less than 1. Just as a check, you haven't made a mistake on your arithmetic. Square root of a 69 is a number between 8 and 9. Okay. So anyway, that's where the square root of 69 over 13 came from right here. You know, the rest of this, it's fairly straightforward. We were just doing this part of the problem. So what I've done is I've added sine x, but notice sine x can be written, some people are a little uncomfortable, you can write this as 13 over 13 out front, right? So when you add this sine x to this 10 over 13 sine x, you get 23 over 13 sine x, all right? Now the next thing we do here is use something called Cauchy Schwarz Inequality. And y'all, I'm going to flash down here. I'm going to show you. Here's a statement of Cauchy Schwarz. It's a famous result. You can trace it back to linear algebra. It's where the dot product of two vectors is less than or equal to the product of their magnitudes. Okay, that's what Cauchy Schwarz says. All right, if you want to think of it in terms of vectors. Here we're not really thinking so much in terms of vectors, but you can see right here. All I've done is the real numbers. So a sub 1 would be this guy right here. B sub 1 would be sine x. B sub 1 is a function, but it evaluates to a real number, right? And of course, this would be a sub 2, b sub 2. And you can see what I've done, folks, is just directly use this result. I won't spend, the proof of this is kind of interesting. And it's very famous inequality. It works for any real number. It's not like the Arithmetic mean, geometric mean inequality is limited to positive real numbers. Cauchy Schwarz handles all values, all values. So it's very it's a comprehensive inequality. All right. Now, if you go through and do the work here, we also exploit the fact that sine squared plus cosine squared is equal to 1, right? Let me put a vertical equal sign. This appeals to this is called the unit circle identity. So that's why this part disappears. Now you can see I've done a little bit of arithmetic for us. It ends up being this if you want to check out the arithmetic. Now, a lot of people wouldn't want to leave the answer this way, so this would be the same thing as the square root of, we can factor a 23 out of both of these, right? 3 times 23 is 69, right? So this would be 23. And I think we're left with 26 here. Yeah, 26. Leaving out a few of the steps, folks. And let me bring this down a little bit. Over 13 squared. Okay, folks. And again, if you're wondering where this comes from, you factored a 23 out. So one of the 23s was left. All right, and then so this should be 23 plus 3 should be 26. Sorry, right there, that should be 26. And guys, you see where that comes from? Factor a 23 out of this, you have 23 left. Then you have 3 left from here because 3 times 23 is 69, right? Now notice right here, this is 2 times 13. So again, let me just get right in here and I'll write just the final answer. This would be the square root of 46 over 13. And you guys can verify the arithmetic, but I double checked it. Square root of 46 over 13. And I'm not going to go to the trouble to simplify this. This is a number that would be less than 2, which is not too hard to see because 52 over 13 is 4, right? And then the square root of 4 is 2. So this, whatever this number is, it's slightly less than 2. Somewhere it's less than 2 for sure. And I'm not going to go to the trouble to do the rationalization. It's no big deal. I'd have to know how to multiply 13 by 46. We can just leave the answer that way. It's fine. It's acceptable. Okay. But again, it goes all the way down. It's the square root of the quantity 46 over 13 is the maximum value. You see, because this is our original expression after we did the manipulations. All right. And it's always less than this number for all x. Okay. So let's come back up here and write the final answer. The maximum value, the max is the square root of the quotient 46 over 13. Okay, see you next time.